In the last class, we were discussing about the physical properties of alcohols. Today, we will see about the reactions of alcohols. So the first reaction is the electrophilic addition of steam, that is H2O gas in gaseous state to an alkene using a concentrated phosphoric acid H3PO4 as a catalyst. So if you do the electrophilic addition of steam in the alkene molecule C2H4 in the presence of phosphoric acid as a catalyst, then you will get your ethanol. So these are the methods of preparations of alcohols. So write it down. This is the first method.
I'm done.
So if I ask you why it is called electrophilic addition of steam, because here we have an electrophile H plus. It will attack to this ethene molecule. This is your ethene molecule. It will act as a nucleophile because it is having pi electron density. It is rich of electrons. That is why it is acting as a nucleophile. Okay, so it will attack the double bond of this carbon atom. Okay, the bond will get shifted here. So when it will attack this, then a formation of carbocation will happen at one position. At one position, hydrogen gets attached. In another position, there is the formation of carbocation. And at this carbocation, your OH minus will come and attack. Okay, so it will become your ethanol. So that's why it is called electrophilic addition of steam, because the electrophile, it is attacking to the pi electron density, which is acting as a nucleophile. Okay, so there's the formation of carbocation. Then your OH minus from water will come and attack the carbocation. Next reaction to prepare alcohols. This is the second method to prepare alcohol. This is oxidation. Oxidation of alkenes with 4 dilute acidified potassium manganate, KMNO4. This whole thing, 4 dilute acidified potassium permanganate, this will give you nascent oxygen as discussed in the last chapter also. So it form a diol, that means 2 hydroxy group. So we can use the symbol O. O in the square bracket means that you are using a strong oxidizing agent, which is 4 dilute acidified potassium manganate. Okay. So when you react ethene with this oxidizing agent, then you have 1,2-diol, ethane 1,2-diol. So this is your ethane, and at first position and at second position, you have diol. So this is the second method to prepare alcohols.
I'm done. No, I was done with the previous page, not this one. Sorry, ma'am.
Sorry?
I was done with the other page, not this one. No, I still have to write this. I'm done.
The next reaction is, this is your third reaction, that is nucleophilic substitution, that is hydrolysis in this case. Okay, substitution of water. That's why it is here written hydrolysis of a halogenoalkane by heating with NaOH. So when you heat your RX molecule, R is alkyl group and X is halogen with NaOH, then a substitution reaction will take place. OH minus come at this carbon. Okay, it will attack at this carbon. Why it will attack? I think this you know by now, because OH minus, it is having the partial negative charge, and CH2, it is having a partial positive charge, because bromine is electronegative. So bromine is having partial negative charge. So this negative will attack to this positive, and this bromine, as it is a good leaving group, so it will leave. So we have CH3, CH2OH plus NaBr. Na, which is positively charged, it reacts with bromine, which is negatively charged. So simple substitution reaction is this nucleophilic substitution of halogenoalkane by heating with NaOH. This is the third method to prepare alcohols.
I'm done. I'm also done.
Okay. So this is the fourth method to prepare alcohols, and this is the reduction method. If you do the reduction of aldehyde or reduction of ketone using a reducing agent such as NaBH4 or LiAH4, you will get your alcohol. So if we represent O in the square bracket as oxidizing agent, we will represent H in the square brackets, which will represent your reducing agent. Okay. So if we reduce aldehyde, we'll get primary alcohol, and if we reduce ketone, we get secondary alcohol. So propanol, it gets reduced to propane 1-ol, and propanone gets reduced to propane 2-ol.
I'm done.
Okay, so this is the fifth method to prepare alcohol, reduction of carboxylic acid. Using NaBH4, LiAlH4, H2 nickel, these all are my reducing agents. So when acid gets reduced, it gets reduced to the alcohol. So when you reduce CH3COOH, we get CH3CH2OH plus water gets liberated out. That means aldehydes, ketones, and carboxylic acids, all three can be reduced to alcohols. All three can be used to prepare alcohol.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
I'm done.
I'm also done.
So next reaction is hydrolysis of an ester by heating with a dilute acid or alkali. So what is the ester? Ester means RCOOR dash group. Okay, R, C double bond O, O, and then R dash or R. Okay, whatever. So R means your alkyl group. So when you hydrolyze the ester like this, okay, in the presence of acid, H plus as the acidic medium, so you get CH3COOH. This bond will break. Okay. Here you have H and here you have OH. Then with alkali, NaOH. Then with alkali you have CH3COO. This bond will again break. But here the cationic part is Na+. Okay, so here we have a cationic part Na+. Okay, and here we are having OH after cleaving this bond. So that means hydrolysis of ester can be done by acid also and by alkali also. In alkali you just have a salt. So this is my salt and this is my acid. That means ester gives you acid plus alcohol.
I'm done.
So methods of preparation of alcohols are completed. These are enough for the methods of preparation of alcohol. Now we study the reactions of alcohol. That means once the alcohol is now prepared, then how it will react. So first reaction is when ignited, when it is burnt, the alcohols react with oxygen in the air. The products are complete combustion, okay, carbon dioxide and water. So when alcohol reacts with oxygen, you have carbon dioxide and water. It is a complete combustion. That's why it burns with a clean blue flame in a good supply of air. So this 3, 2, 3, these are just to balance the equations. Otherwise, your alcohol reacts with oxygen to form carbon dioxide and water. So this is the first reaction, that is combustion reaction. Okay, so the next reaction of alcohol is, yes, so this is an important point. It can come in MCQ in 1 marks, that the fuel called gasohol, it is a mixture of ethanol and petrol. Write it down. Next reaction is the substitution. Next reaction is the substitution of to form a halogenoalkane. This is also a reaction of alcohols. So when it reacts with hydrogen halide, okay, it may be HCl, HBr, it will give you halogenoalkane and water. So this reaction we studied in the method of preparation of halogenoalkane in the last chapter. Substitution reaction will occur. Cl will take the place of this OH and the H2O gets liberated out. Okay, so the dry hydrogen chloride gas for this reaction, this HCl, where does this HCl is coming from? Where does this HCl is coming from? So the dry hydrogen chloride gas for this reaction, it can be made in situ in the reaction vessel. Sodium chloride and concentrated sulfuric acid are used for this. So this is that gas which we have used here in this reaction. When sodium chloride reacts with sulfuric acid, we get sodium hydrogen sulfate plus this gas which is used in the preparation. Okay. In situ means in the reaction vessel, in the within the reaction mixture.
I'm done.
Now for substitution reaction with hydrogen bromide, the HBr can be used. The HBr can be made using potassium bromide and concentrated phosphoric or sulfuric acid. The nucleophilic substitution by the halide ion, it will take place after OH group has accepted an H plus ion from the acid. This makes the CO bond in the alcohol easier to break and water is given off. Sulfur dichloride oxide, it can be used to substitute a chlorine atom into an alcohol molecule. So I hope you remember this reaction we studied in the last chapter also, when alcohol reacts with SOCl2 to get RX, method of preparation of halogenoalkane, where HCl and SO2, both these are gases, so they just evaporate. So this is a good method, very good method to prepare halogenoalkane, because other two byproducts are gases. So we get pure RX compound. So this is the reaction of, this is now in this chapter in the reaction of alcohols. Okay, so this is for the substitution reaction with this. If you want to take HBr in place of HCl, so here it is written, you can take by using potassium bromide and concentrated sulfuric acid. Okay, you can take potassium bromide instead of NaCl and concentrated sulfuric acid, H2SO4. You will get HBr from here.
I'm done.
So in this reaction, two byproducts are gases. These gases escape from the reaction mixture and the halogenoalkane is formed without the need to heat the reaction mixture again. So this is a good method to prepare halogenoalkane.